Ms. Priti Pandey is there from my team. So I'll be presenting our Kaizen on optimization of APC using AI-based web application on the renovation category. Our improvement team, the project was sponsored by our DQC chairman, Chief Haldia, Mr. Anil Paul, and the project was led by Mr. Rajan Kumar Behra, head Haldia operation, and other team members are from various departments. So coming to the Haldia generation plant, Tata Power Haldia generation plant is a unique plant. So we are a co-generation plant. We situated with the same premises of Tata Steel. So Tata Steel have coke ovens batteries. From that coke ovens, hot flue gas is getting evacuated. So we are using that hot flue gas and generate steam in our waste heat recovery boilers. So using that steam, we generate power in our three number of TG sets, two of 45 megawatt and one of 30 megawatt. So we have total installed capacity of only 120 megawatt. And that generated power then getting evacuated through WBSATCL transmission network, and power is getting sold through TPTCL, our trading partner. Then that power is getting sold in farm power cell, and then term wire market, day market, and real time market. Basically, we don't have a long-term PPA with any discom. We classify it as a merchant cell business. So we have taken this project based on our problem bank prioritization project selection methodology, and the trigger for this project came from the problem bank for FY25, and based on the nature of the challenge and cost solution matrix, we have taken up this project. This project was in alignment with our generation cluster strategic objective of benchmarking operational parameters and optimizing cost through utilization of innovative ideas and digital interventions. And in alignment with that also, we have taken key KPIs of auxiliary power consumption of Haldia in our Chief Haldia scorecard also. So the main business objective and aligning with the Tata Power vision of empowering 1 billion lives through sustainable, affordable and innovative energy solution, this project plays a critical and pivotal role. And it was also taken in alignment with the CII regulation for the APC guidelines, and obviously in alignment with the UN SDG goals of 12 responsible consumption and production. So the APC trend, as you can see from FY18, we are in a improving trend, and in FY24 our achieved value was 7.16. So that was our internal benchmark since inception, and we have taken a aspirational target of 7.1 in FY25. This will increase our sales volume by around 0.57 MUs. So this was a key project for us, and achieving that target will be much more crucial for success of our business. So we have done the capability analysis of the APC data points for FY24, and from that we have found out the mean value was 7.2% and short-term sigma capability was only 4.33%. So there was a scope of improvement for us. So we further develop the cause effect matrix, Fishbone diagram, and from that one of the major cause was lack of monitoring tool for proactive action for real-time adversaries that was missing in our case. So based on the cause effect matrix, we took up this cause of lack of monitoring tool and for proactive action, and further deep dive and do the why analysis. And from why analysis, what we get, improved APC prediction led to reactive actions, and variation of APC was observed. And then APC was predicted by manual data analytics previously what we are doing, and then the digital application was not present earlier for better accuracy in APC prediction, and further lack of awareness in the field of machine learning was there, and digital drive in this business context was missing in our case. So we have taken the help of corporate DNIT team to develop this tool. So I've already described the problem statement. So to maximize the net export part, we have to either improve the generation part or reduce the APC part. So we have focused on the APC part, and implementation of this tool, AI-based web application with the support of corporate DNIT team, it will give us real-time and historical data analysis to support timely, corrective and preventive actions. So accordingly, we prepared the project charter, linking all the critical KPIs, EPM processes that we have, and clearly defining the project timeline in our project charter. So from approach to benefit, in the approach part, data collection, data analysis, model development, deployment and data validation part. Key deliverables was correlation analysis using heat maps between the controllable variables and outcomes, real-time tracking of APC of 6.6 kV for 50 drivers, and integration of the predictive models. The benefit would be improve the APC figures leading to enhanced thermal power plant efficiency. The goal of this APC optimization ML model is to transform the thermal power plant operation by leveraging advanced analytical and machine learning techniques. So accordingly, this is the project execution journey from April onwards to September. We jotted down all the steps and completed the project in the month of September. And these are the major tools that we have used in our project execution, like Python, Angular, Node.js, AWS, and data source was from DCS, PyAVT systems, and so on. So I will just broadly describe the major steps in this tool development. So firstly, we do the historical data frame for the first 6 months, then do the descriptive analysis, then found correlation among the input variables, and finally prepare the regression model for our tool. So initially we are doing based on the Excel based tools. Later stage we have developed a Py-based tool, but ultimately we have developed this CII based web application in which you can clearly see there are certain advisories, real-time advisories are coming, and we compare the real-time APC value with the historical best estimate value, and we take proactive actions so that we can reduce the APC on real-time basis with real-time actions. So main features of this tool is real-time monitoring, trend analysis of significant energy units, and there is a hooter alarm that is provided for the control persons. So using this APC, after improvement we have done the capability analysis, and the sigma value was improved further to 5.4 level, which was a major improvement for us. And in the box plot also you can see the mean value was reduced to 6.86%. The major key benefits that we have achieved through this project is enhanced operational efficiency. Real-time monitoring has helped us in this. Then cost reduction obviously by minimizing the APC, and real-time decision making and increased profitability. So through this project we have gained revenue of 1.2 crores in FY25, and there is a potential of after horizontal deployment in generation cluster around 5 crore in our Tata Power. So as you can see in terms of APC also in FY25 we have achieved 6.95, which is our internal benchmark, and which is also a huge gives us huge benefit in terms of revenue part. Sorry, this is the benefits in terms of PQCDSL. Here the main part is cost optimization. So there was increase in sales volume. In addition to that, this tool was developed by in-house talent. So no third party was no help from third party was taken. So completely in-house developed. So there was a huge cost saving from this project. This is the saving validation by our divisional CFO, and as you can see 1.2 crores was saved in terms of revenue in FY25. This was the training and SOP revision has been done in our ENMS SOP, and through Delta Digital platform this improvement has been shared across Tata Power for further adoption. And we are the winners in FY25 Generation Cluster Delta competition for this project. And in way forward, we will be upgrading this model by new data, incorporating seasonal changes with appropriate data, and inclusion of new features like improvement level analysis. So thank you, and I will close my presentation by the tagline sustainable is attainable. Thank you, sir.